So when I was designing this, I thought, well, how should I start? Actually, let's just start with the definition of archaeoastronomy, so we're all on the same page here. This is my definition. Archaeoastronomy is the study of how people have understood, conceptualized, and used the phenomena in the sky, and what role the sky played in their cultures by analyzing their material remains. Now, why? Why should this be a thing? Why should this be an academic field? Well, there's a lot of evidence coming out of the historical record and the ethnographical record that indicates that all cultures have had a special relationship with the sky. For instance, Nicholas Campion, a historian, opens his book that surveys the historical record for people's engagement with the sky by saying there's no human society that does not somehow, in some way, relate its fears, concerns, hopes, and wishes to the sky. The title of his book, Astrology and Cosmology in the World's Religions, emphasizes one aspect of that we still have around us today, which is astrology. It is one way of engaging with the sky. It's one way of relating people's fears, concerns, hopes, and wishes to the sky, regardless of whether it's valid or not. That's not the point. We're doing humanities here. We're not validating anything. And in the book, he basically surveys historical record of most cultures across the entire world, and he keeps finding evidence for either cosmology or astrology or astronomy, whatever we want to call it. Stanislav Ivanizevsky here is a Mesoamerican archaeologist. He uses a lot of ethnography in his studies, and he's here talking through or based on the ethnographic evidence, on the anthropological evidence. For many societies, important celestial bodies are perceived as animate entities, and their motions in the sky are described in terms of social relations. Human societies often people their skies with supernaturals, ancestors, mythological heroes, to whom they become related through family ties, mythological narratives, political alliances, or power relationships. If you know a little bit about the constellations, if you've learned that in the past, you know that we are doing this as well, or we have done this, because we've inherited our constellations from the Greeks, and the Greek myths are projected in the sky as the constellations. So it's not just ethnographically studied societies that have done this. Historical societies have done that as well. Now, academically, archaeoastronomy is part of a larger field, a larger subject matter that we've come to call cultural astronomy. It's the intersection between astronomy and the humanities, if you want. And this is an umbrella term that actually covers a lot of different things. On the one hand, we have history, the history of astronomy, the history of astrology. Of course, both things were completely interrelated until the 18th century. On the other hand, we have ethnoastronomy, which is the study of the relationship between people and the sky based on the ethnographic record. So this is what anthropologists would do, people in this building. And archaeoastronomy, which focuses on the archaeological record, what people in the other building next door will do, and what I do. And so I'm focusing on this, even though there's lots of cross-cutting in theoretical and methodological terms between all of these fields. Traditionally, however, archaeoastronomy is even narrower than the definition I presented earlier, because traditionally it has focused on the study of the orientations of monumental structures, in particular trying to identify intentional celestial alignments. What am I talking about here? Lots of big buzzwords here. Talking about something like this. This is a photo of December solstice sunrise at the Temple of Karnak in Upper Egypt, or Southern Egypt. Present-day Luxor, ancient-day Thebes. Capital of Egypt for a very long time. And one of the largest temples in Egypt, in fact. And what we have here is some architecture, which unfortunately you can't see, but we have the sun rising here, passing through this threshold, on top of this threshold, and in between these pylons. So this structure, the architecture of this structure, somehow manages to capture an alignment with the sun on December solstice. So this is the sort of thing archaeoastronomers are looking for all the time. But the very important keyword is that one, intentional. Because things like this happen all the time by chance alone. For sure you've noticed this in your house, particularly if you have a desk, if you have an office in your house, and you're trying to work and you have a window in front of you, you will get the sun in your face, and you know how horrible that is. And you also know that if you wait long enough, the sun's going to move away, and that if you're working in a different month, a different season, the sun might not even affect you at all. So things like this happen by chance all the time. The question is to argue for intentionality, to demonstrate that this was intentionally designed by the ancient Egyptians, and then to ask why. Oh, I must have deleted a slide. Anyway, I can wing it. The point is, this search for alignments has a very long history. It predates archaeoastronomy as defined as an academic field. It predates archaeology, defined by an academic field, because it goes all the way back to antiquarianism. So we're talking here 17th, 18th, 19th century, before archaeology, but the very basis of archaeology. Antiquarians who were traveling the countryside and excavating stuff, not really knowing what they were doing, and also speculating about the things they were excavating, again, not really knowing what they were doing. But some of them, because they were heavily inspired by the classical writers, and of course the classical writers wrote about temples of the sun god and of the moon god, they started to bring these concepts and apply them to the monuments that dot the British landscape. And that's how the search for alignments really began. Unfortunately, archaeology eventually coalesced from within a group of antiquarians, which really didn't engage with astronomy. So the two kind of diverged for a while. And then in the 1960s, Gerald Hawkins' book Stonehenge Decoded, which is still in print, but I don't advise you buy it. It was published, and it was the first time archaeoastronomy really came to the public's attention. And in the book, Hawkins used the computer. It was the first use of a computer in the social sciences. This was the 60s. We're talking about computers the size of a room, right? They weren't readily available as they are today. But what he did was he took the plan of Stonehenge as drawn by archaeologists, and he inputted the coordinates of all the stones at Stonehenge, but also all the holes, the sockets, that might have had stones. And he had the computer run through every single combination of 2 points or 3 points, so every possible alignment, and then try to find which of those matched the rising and setting of the sun and the moon. And of course, he found lots of stuff. And he found so much stuff that he even claimed Stonehenge was a Neolithic computer. That's the title of one of the chapters. It's actually the title of a paper that he published in Nature that before the book was published. Nature. It was a computer because he thought that he could use the Aubrey holes to estimate or calculate or predict eclipses. So he thought that because he could do that today, that Neolithic people 5,000 years ago were using it for the same reasons. As you can imagine, this did not sit well with the archaeologists, who had a completely different vision of prehistory. Scientific man and prehistoric man were incompatible. So there was a huge quarrel. And this quarrel led into archaeoastronomy kind of disappearing into the fringes. To be honest, there were very few people working in archaeoastronomy at the time. Alexander Thom was possibly the only person who kept the field alive through the 70s. He was an engineer and a surveyor. He was a very good engineer and surveyor, and he surveyed almost everything in the country here. He moved away from Hawkins into a more of a statistical approach. He was looking for patterns, because if you find that this stone circle has these particular alignments and this other stone circle has the same alignments, then it's a pattern, then it's less likely to be by chance alone. The problem was that he was selecting his stone circles very carefully to find patterns. And this was later in the 80s and 90s proved by Clive Ruggles, who did a more complete statistical study and really demonstrated that there was selection bias. But the field today is thoroughly based on fieldwork, and that's from Tom. That comes to us from Tom, on going to the sites and measuring these sites, measuring these orientations rather than putting them on a computer based on a drawing that somebody did, and that has unknown precision or accuracy. And that's where we are today, and that's the slide that was missing. But to do that, we can be excellent surveyors, we can be excellent astronomers, or mathematicians, or archaeologists. But what we really need to do to grasp this is we need to have an understanding of what's happening in the sky. And that's something that unfortunately we modern Westerners lost completely. Because of light pollution, because of skyscrapers, because of so many reasons, because of life down here that is so busy. We've lost it. We lost that connection to the sky. And this is the most difficult hurdle to overcome here. I'll explain why in a second. I thought I had something else to say here. It will come back to me. I'm going to show you 3 different representations of the sky. You are all familiar with it. But I'm going to force you to look at it in a different way. Let's put it this way. Here's a representation of the sky that comes to us from astrophysics. The sun is at the center of the solar system. The Earth rotates around the sun. The moon rotates around the Earth. We all know that this is reality. This is what's supposed to be happening, right? And we see this whenever you get an astronomy book, an astrophysics book, you will see something like this, right? But pay attention to the perspective. Where is the observer here? It's floating in space, somewhere in the solar system, not on the Earth, somewhere in space. That's not human experience. You can't experience that. This is a construction, a mathematical construction, geometrical construction by astronomers. I'm not saying it's not valid, but it's not human experience. A second approach that for those of us in the room who did physics, also saw it a lot, because this is how we learn celestial mechanics, is that. So astronomers are very prone to using this. This is better because, as you can see, it puts the humans in the middle. There's a bit of a landscape, if you want, north, south, east, west, little human being there, and we have the celestial sphere around. There's the sun there, and this is the path of the sun. The sun would rise here, and as the day progresses, it follows this line, and eventually it sets, and it does that throughout the night, which we can't see, because we can't see anything below this gray plane. These are also the north and south celestial pole. But again, look at the perspective. Where is the observer? Somewhere outside the celestial sphere. Again, that's not a human view. Maybe the gods can see from the other side of the celestial sphere, but we can't. What we do see is this. We have a horizon which is more or less flat. In this case, I've made it flat because it's easy. We're facing south. East is to our left, west is to our right, and that's the sun, and that's the path of the sun. So we actually see the sun go around the Earth if you want, but that's not to say that that's how it's conceived by every culture. But this is the raw data that every culture has, not this and not that. This is what is actually empirically observable, and this is what we need to bear in mind. This is how we need to look at the sky if we are to start to comprehend how other cultures look at the sky and what they see when they look at it. And this is a difficult jump for archaeoastronomers because most archaeoastronomers are trained in astronomy. So they're used to thinking like that and like that, not like an anthropologist who has been in the field and has observed this. So I propose that in the next few minutes, can you give me a 15-minute warning? I forgot to...
For the very end?
Yeah.
Yeah, I mean, what do you want to do? Do you want to say another... Shall we stop at 7:45?
Yeah, that's how I prepared it, 1 hour, yeah. Thank you. So for the next few minutes, I'm going to run through what things are doing in the sky with these fresh eyes. Not the astronomer's perspective, not the astrophysicist's perspective, but but an anthropological perspective. The bare bones that perhaps will make you look to the sky in a different way. Now, when I do this, I always start with the stars. And there's many reasons for that. I would claim, and I will claim by the end of these few slides, that they are the simplest object in the sky. So that's why I start with them. But also they're ubiquitous. Yes, the sun is there and we all feel it. We can't really see it because we go blind, but we feel it. We feel its effects. But when the sun sets, the stars are everywhere, unless of course you are in the middle of London. There are over 7,000 stars that are visible with the naked eye. Again, not all of them are visible from everywhere, and not all of them are visible for everyone, because it depends a lot on the binoculars that you have, the naked eye, I mean. And of course it depends on light pollution, it depends on your altitude, but this is the maximum number of stars that are possible to see with the naked eye, and that's a lot. 7,000 stars. They are everywhere, as you can see in that fantastic photo. So there's a great many of them, but they are not all equal. Some are brighter than others, some have colors, some twinkle a bit more than others, etc. So here's an image of the constellation of Orion rising above the temple of Kukulkan in Mesoamerica. And you can see that there's clouds here, but above it you can see the starry sky, you can see many, many stars, but these ones just pop out, and that's what we call the constellation of Orion. And you can see this one, Rigel and Betelgeuse here, are brighter than the others. You can see this is light blue and that's orange, red. So they are different. You are drawn to them when you're looking at the night sky because they are brighter, they are different. So not all stars are the same, but they all move in unison. You don't have one star moving now while another waits, and then that doesn't happen. They all move as one. And that's why the Greeks discussed them as the fixed stars. They thought they were holes in the celestial sphere, and that it was the celestial sphere that was moving, rotating around the Earth. And that beyond there was pure light. So the holes would give light. But each of them has its own paths. So the paths don't cross. You don't have a star going this way and a star going that way and eventually colliding. They're all moving in parallel. And that's what this collation of shots taken at... I forgot to put that information. Anyway, you know what this is. It's just tracking the star trails. It's a long exposure photo. That's what I meant to say. But, and this I think is crucial, when you see them rise or set, they always rise or set in the same place on the horizon, if you are on the same location, of course. So if you see a star rise today from your backyard, and you go and check tomorrow, the star will rise on the same place, above the same house or tree or hill or whatever. And the same is going to happen the day after, and the day after, and the day after. There's regularity here. There's prediction. You can predict where the star is going to rise or set. This doesn't happen with all stars, because not all stars rise and set. In fact, not all stars, even stars that rise and set, tend not to do that in the same night. But that's a bit more complicated, and I have a lot more stuff to talk about. But I can talk about that later in the question time, the different types of stars we have. But those that touch the horizon do so in the same spot, always.
For a given altitude?
For a given location, even, yes. Because it depends on the horizon, right? Now, due to their positions, with respect to each other, and because some are brighter than others and they have colors, you can join the dots and you start to see patterns. And that's what we call the constellations, or asterisms, which are just smaller parts of constellations. So here we have the asterism of the Big Dipper, which is part of Ursa Major, the Big Bear constellation, which actually looks more like that. And which we inherited from the Greeks, this idea that this is a great bear. Now you can't see a bear here, but if I tell you this is the tail, that's one leg, and that's the torso. The head would be here, and another leg. Then it starts to make sense. But I want to focus on the Big Dipper here and show you that other things are possible, and that indeed other cultures see completely different things based on the same sky, the same information, the same data. The ancient Egyptians saw a bull's thigh and leg, if I want to be accurate. So that would be the leg, the thigh, the tail of the bull, and there is no rest of the bull. It's just a thigh, actually. And it's the most important constellation in ancient Egypt, and it's the one we know better. For the Chinese, it was the wagon of Emperor Shangdi, which was a mythical, cosmical emperor for the Chinese. And of course, we also have Charles Wain, don't we? Which is the Big Dipper as well. So it's a similar concept. But for instance, in India, and of course in India there are many traditions, and not all of them are the same. This is one. They actually don't connect the dots and see a large image. They see each star as an individual. And what they see are the 7 sages, which have a mythical correlation in Hinduism. And this is actually a trait of many hunter-gatherer societies, is that they don't join the dots and see a larger thing. They think each star has its own individual, and they are relating and interacting, but they tend not to see a big thing. Not all. This is talking in general here. And for the Iroquois, it's also a bear. That's interesting. But there is no tail of the bear. There are 3 hunters that are hunting this bear. That's a man carrying arrows, in case you're wondering. Constantly hunting this heavenly bear as the constellation goes around the celestial pole, which is somewhere here. These hunters are constantly tracking this bear, never reaching the bear. So different cultures see different things, even though the sky is the same, more or less the same. So the point I'm trying to get across, which is something that unfortunately you see a lot in speculative archaeoastronomy, the lunatic fringe more, is that we shouldn't assume that what we see in the sky is what other cultures saw in the sky. So we can't just assume that the people who built Stonehenge also saw a bear when they looked at this. I mean, it could be a frying pan or whatever. Of course, it wouldn't be a frying pan for them. A cauldron. Yeah, exactly. Something like, it could be anything. So unless there's evidence, we shouldn't really just assume those things. That would be anachronistic and ethno-projection. But the largest victim of the West is the Milky Way. We just lost the Milky Way. It's gone. I mean, we can still see Orion even from London, but the Milky Way, it's very hard to find these days. I mean, to be fair, there's lots of places in the world that are still far away from civilization and where you can still get this. And we're trying to preserve the few in the West that still allow this, and we call those the dark sky parks. So for instance, you can still get this from the Mayo Dark Sky Park in Ireland, which was the first gold dark sky reserve in the Northern Hemisphere. But of course it's Ireland, so it's going to be wet and grey most of the time. But if you're lucky, you will get something like this. I actually think this was taken in Mayo. It was certainly in the Dark Sky Park, I'm not sure. And if you do get that experience, and I suggest that if you haven't done that, you put that in your bucket list, it's remarkable. It's a unique experience. You will actually see that the Milky Way casts a shadow. It's so bright where you're in a dark sky that you can see the shadow of trees. In a moonless night, it's the stars that are casting a shadow. And this is something that has been considered anecdotal by astronomers for many years, because astronomers tend not to actually go out and look at the sky these days. They just look at computer screens. So that's it for the stars. The second object that I speak after the stars is the sun. The first thing to know about the sun, and I'm always surprised by the amount of people who don't know this, is that the sun doesn't rise in the east every day, and it doesn't set in the west every day. It does if you consider east very loosely and west very loosely, but east and west are specific points of the compass. Pick a compass, east is 90 degrees and west is 270. And the sun doesn't rise at 90 degrees all year. It does so only 2 days in the year. So here's a reconstruction of the sky for today at 5:25, well, a while ago, from the North Circle of Avebury. This is a panoramic shot that was taken, and then I'm using the software called Stellarium, which is free. I have a link in the last slide, which you can use to reconstruct the sky from any place on Earth from any moment in time. And you can see that, oh sorry, this is AM obviously, 5:25 AM, the sun was rising here, rose here today. If you go back a month from now, oops, so 19th of July, you see the sun was rising there and is now rising behind this tree.
Forward, ahead. Forward a month or back a month?
This is forward a month, July. Then a month later, it rises there. And then in September, it rises behind these trees. So it would have risen maybe here, and then it does that path. So you see, it does this thing. It's constantly moving every day. Well, almost every day. But it doesn't just keep moving, like all the way around. It does so within limits. Those limits are what we call the solstices. It's a crappy image. I apologize for that. If you're looking south, and that's the horizon, that's east, this is west, and this is the orbit, the path of the sun on December 21st, on March 21st or September 21st, it rises in the east and sets in the west, if you have a flat horizon. And in the summer, June 21st, it does that. In between, it's moving like that. So in the summer, it's here. In the autumn, in the winter, in the spring, in the summer, etc. Ad eternum. Keeps doing this. It's like a pendulum, moving on the horizon. And like a pendulum, it kind of stops before it changes direction. And that's what we call a solstice. It means the sun is standing still. Of course, it's not the sun is standing still as in apparitions of the Virgin Mary in Fatima. It's the sun's position on the horizon is standing still for about a week. The sun seems to rise from the same spot of the horizon for about a week. So if you go to Stonehenge today, you'll see the same that people are going to see in 2 days when the big party is. It's exactly the same. The sun is actually moving, but it's imperceptible to the naked eye, the difference. And like a pendulum, when it resumes its movement, it's going to speed up, and it's at its fastest speed around the equinox, which is why the equinox is so hard to pinpoint, unless you have modern instruments. And that's what I'm trying to show here. If this is a solar disk, and that's the size of the disk of the sun, around the equinox, you see that from one day to the other, the sun moves about its size, which is half a degree. Whereas at the solstice, for about a week, it's going to be basically standing still. That's the solstice. And then it takes weeks to pick up speed. So it's slower around the solstices and faster around the equinoxes. When you observe this, let's say you are settled, you are in a sedentary society, a farming society. It doesn't have to be a sedentary society, but just for ease of use. And you have always the same horizon, the same environment, the same landscape around you. You're so used to it, it becomes second nature. And you start to observe the sun and where the sun is rising or setting. And then you start to see that the sun rises and sets in the same points of the horizon every year. And you can make a calendar out of that. And this is what the Hopi did in North America. This is still the best example we have of a horizon calendar, where they know that the sun will set here on January 20th. But, sorry, I meant to start there. On November 24th, at this notch. And what that means is, ignore the modern date, because that's completely meaningless for them. What it means is that the solstice is going to happen in more or less 1 month, right? So they need to start preparations for the massive feast that they do around the solstice, which brings together many different tribes or clans. So they do that, and they start preparations, and then they have other observations. Actually, observations begin on December 2nd. And then they keep observing it almost every day to make sure that they are on time, that they are on schedule for the solstice. We're talking about organizing a massive celebration across a vast territory and a vast number of people. They need some sort of universal clock to do this, and that the sun and the horizon provides that, much like the moon does that. I mean, if you don't have a calendar, how would you here say, well, it's a month from now? You don't have a calendar. But you know, well, you look at the moon is in this phase on this day. When it's approaching this phase again is when the solstice is about to happen. Because that's where the concept of the month comes from. It's a month, right? Which I'm going to talk about next, the moon. First thing you notice about the moon is that it has phases. You all know that. Which phase is the moon in today? So shy.
Crescent.
Crescent? Fair enough, but which crescent? Yeah, waxing, exactly. Good, good. It was dark moon about a week ago. And dark moon is what we call this, when you can't see the moon. And then the first thing you see is the first crescent, or the new moon, or the waxing crescent. And it goes that way, and that, and this is basically a week each, till you get to the full moon, and then it goes waning and disappears. And this takes a month, about 28, 29 days, and that's where the concept of month comes from. But these phases relate the moon, the sun, and the horizon. You will never see a new moon or a waxing crescent in the east when the sun is rising. You always see them when the sun is setting in the west, because they are always to the left of the sun. So, yeah, is that logical? 12 hours later, when the sun is rising, because the moon is to the left of the sun, the moon is only going to rise after the sun. But because it's so close to the sun, you won't be able to see it during the morning. So you only see it when the sun is setting. Conversely, the waning crescent, the last crescent before dark moon, is only seen when the sun is rising in the morning. And in between these two, you have the full moon, which is always in opposition to the sun. If the moon is rising, the full moon is rising, it means the sun must be setting. And if the sun is rising, it means the full moon must be setting. Always. There's a meme going around social media every so often where there's a picture of both sun and full moon, one on top of the other, and there's a massive tree as well. And they say, oh, this is a fantastic event, it happens once every 500 years. No, it doesn't. The full moon and the sun are always on opposite parts of the sky. You will never see them next to each other. Let's keep that in mind. What about its motion on the horizon, like the sun, the pendular motion? Well, the moon is incredibly more complicated than the sun here, and that's why I'm talking about it last. Because, ignore this, because what it's doing is that it does that pendular motion every month, throughout the month. It's doing that. But then the sun is also doing that much more slower movement throughout the year. And the moon is tracking the sun. So what happens is that we have something like that, which is quite complicated to track. But this movement means that there are extremes, and those extremes are well known. And those are what we used to call the major and the minor lunar standstill. We're now trying to change the terminology, because the moon doesn't stand still like the sun. So let's not use standstill. Let's call it the major and the minor extreme. This is something that Lionel actually has started, and I completely agree with him. And this means that on a given horizon, in this case again, Avebury North circle, you can map out, and this is again in Stellarium, the key positions for the Sun and the Moon on the horizon, where you might expect to see alignments to the Sun or the Moon. So you have June solstice Sun, which rises here and follows the red line, but the Moon as its extreme is going to be in between these two lines. So for instance, the winter full moon is going to be somewhere in between these two lines, and the summer dark moon is going to be in between those two lines as well. The time it takes for the moon to move between a minor and a major is 8/9 years. It's about 8.6 to be accurate. Yeah, 8.6 years. Which means that this is only repeated every 19 years. So it's not something you would experience every year. Which makes it both more complicated but also much more spectacular when you do see it. So, that's it. That's the intro. These are the basics. Some things you probably knew before, others you probably didn't. But these are the bare bones that everyone, every culture will notice when they look up. They might not see all of this, but they will see most of this. Some cultures might see some of these elements, others focus on other elements. But that's it. Those are the bare bones. These are the things we need to keep in mind. And then obviously we look at the archaeology, we look at the structures, we look at the monuments. And we try to identify alignments to those key celestial events that I mentioned, the solstices, the lunar extremes, or even stars rising and setting. So rather than talk about my own research, which I did a few months ago, I'm just going to give you some iconic examples, because it's supposed to be Archaeoastronomy 101. And you all know where I'm going to start, with the major event of the week, the summer solstice sunrise at Stonehenge. That's what it's going to look like, even though it's a picture, I think, from 3 years ago. Tens of thousands of people gather there. You all know this. Rag used to do this. And what you have is the Heelstone, which, if you've been to Stonehenge, you know what I'm talking about. If you haven't, the Heelstone is a stone that is outside the actual stone circle. It's at the entrance of the avenue. So it would mark the position where people would actually come in to Stonehenge in the past, 5,000 years ago. And from the center of the circle, you see the sun rise behind the Heelstone, which is a fantastic and singular experience. But that's not all Stonehenge has to offer. The main axis of symmetry of Stonehenge, which indeed there is an axis of symmetry. I mean, this is how Stonehenge would have looked like 5,000 years ago. There's a ring of trilithons, these three stones around, and then there's a horseshoe of much taller trilithons, and then there's the fabled blue stones that they dragged all the way from Wales, apparently, or not. There's lots of debate. There's lots of debate last week about this, actually, so the jury's still out. But anyway, the point is, you have circle, you have a horseshoe, you have a very clear axis of symmetry here, which is more or less this black line. And that axis of symmetry matches summer solstice sunrise and winter solstice sunset. There's two stones there. Not all archaeologists agree with that. One of them is the Heelstone, but the other, there's a stone socket there, but maybe that's where the Heelstone originally was. Regardless of that, the axis of symmetry is there. It provides two alignments. The question that we face is, which one would have been intentional? Would both have been intentional? Or is one just a spandrel, just happening by chance? Because if you do create an alignment to one of the solstices, you are likely to create an alignment to the other solstice on the other side, depending on the altitude of the horizon. Because they form basically a line, you always get this duality. And the rest of the archaeological record can help with this. I'll talk about the architecture next, but first, the Stonehenge Riverside project that was led by Mike Parker Pearson, who works next door, has excavated the site of Durrington Walls, which was the settlement that we now believe was being used by the users of Stonehenge. This is where they were staying. It was the camping site. And there's lots and lots of evidence for feasts at Durrington Walls. There's lots of pig bones, there's lots of cattle bones. Cattle that was coming from all over the country, in fact. And a very clever group of people analyzed the mandibles of the pigs, because the mandibles, some of them have teeth, and of course you can cut the teeth and you can look at it and date or age the pig at death. How old were these pigs when they were culled for the feast? And this is what it looks like when they've analyzed 201 mandibles, and this is the age in months, so 1, 9, etc. And that's just the number of mandibles of that age. And what you see is a continuum, but massive peaks around the winter. The first winter of the pig, the second winter of the pig, the third winter of the pig. So they were culling more pigs in the winter than in the summer, which puts a lot of the emphasis on the winter alignment, even though something might still have been happening in the summer. But this was actually already obvious in the architecture, and Lionel has been a proponent of this for many years. This is an artist's rendering of what Stonehenge would have looked like 4,500 years ago, in its most developed phase. Those are the stones, these are the so-called station stones. That is the actual henge. That's the heel stone. No, sorry, that's the heel stone. That's the avenue, the so-called avenue. They basically cut down into the chalk, that is the bedrock here, to create this route that follows the axis of symmetry of Stonehenge. But it's going downhill to Stonehenge bottom, in fact. If you were here and you were looking out this way in the summer, and you were then going to use this route for some reason, you're kind of missing the point. It would have been better to come into Stonehenge from this side, stay here for the big alignment, and then just leave. If you're processing this way, your back is towards the main event. It's kind of contradictory. But if the main event is the winter solstice sunset somewhere here, then when you're coming in that way, you can see here the shadows of the stones. And it creates a very nice effect, particularly because there's about 5% slope. So you are walking uphill. And if you're walking relatively slowly, what Lionel would say processional speed, you can basically counteract the movement of the sun as it's coming down. And then when you reach the heel stone here, what you would see was something not unlike this, except that there were a lot more stones than there are today, and the only gaps, the only windows, would be this one here and one above it. All of this would be covered, 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 covered. So Stonehenge would look like a wall of stone with two windows. And in one of these windows, you would see the winter sun setting. And this is actually the summer solstice rising here. This is a picture taken from the other side. But that's not. That's a picture I took in 2009. Unfortunately, it was cloudy, and we didn't quite get the sun disk. But you can still see how visually striking it is, even though these things would have been covered and all the light would be coming through this window. Now, let me tell you from experience, being there for December solstice is painful and miserable. Because it is Salisbury Plain, and yeah, it should be renamed Salisbury Plain in the winter. But regardless of that, it's quite spectacular. But furthermore, Lionel, I don't have an image of that, but Lionel has found out that the second window that would be here would actually capture the moon at a minor lunar extreme year. So at a minor lunar extreme year, every 19 years, you would get the sun setting here and the moon setting there, and that would be the longest, darkest night you can possibly get. Because it's the longest night of the year, and it's a moonless night, because it's dark moon. And that fits in with Lionel's solarization of the moon interpretation of Stonehenge, which I'm not going to go into detail, because I assume he's given a talk, or he's going to give a talk.
Not this year, actually. Yeah.
Not this year, okay. The next time, tell me that, and I could actually prepare a few more slides on his stuff, because I'm happy to do that. So Stonehenge is still the most iconic site we have in terms of archaeoastronomy. The archaeology supports the archaeoastronomy. It's phenomenologically fantastic experience, so everything just comes together nicely. Unfortunately, for other sites, that doesn't happen. Avery is complicated. Lionel has a fantastic idea of Avery as the underworld, which I think is just right. But Avery is a lot more complex as a site. And unfortunately, it's under-researched because it was basically destroyed by the antiquarians, sadly. But yes, there's a lot to be said about Avery. We can talk a bit more about that in the questions. The second, perhaps most famous example is Newgrange in Ireland, which features an alignment to, again, December solstice, but this time sunrise. And this is the sort of thing you would be able to experience if you go there. Of course, there is a 20-year-long queue. So if you register now, you will get in 20 years to see this. And if you're not familiar with Newgrange, Newgrange is a completely different type of site. It's a passage grave. It's from 3000 BC, so slightly older than the most complex phase of Stonehenge. It's a mound, an artificial mound that is covering an internal megalithic skeleton that has a chamber and a long passage. Ignore this facade, which was reconstructed in the 70s, and it's clearly wrong, but anyway. It features an entrance and a roof box. And this roof box is original. A few months ago, there was lots of discussion in the social media that this was created by the archaeologist, but actually, we have photographs from before the excavation and the reconstruction that show that this roof box was already there. And this is the key feature, astronomically speaking, because what happens is that when the sun is rising at the December solstice, light will come through the roof box and hit the back of the chamber, where there is a stone basin with a hollow, which if it was holding some water or oil or some reflective liquid, beer, whatever, well maybe, yeah, well no, it could be beer, they already were farming, would reflect that light and obviously illuminate the chamber in that way that only natural light can do when it's being reflected in water, right? And of course, the stones in the chamber are all carved much like this. It's a key feature of the Neolithic in Ireland. And so today, this is what you experience. If you put the camera in that stone basin, you see that. We don't really know why. There's lots of missing answers to the question why here. Another example, further away from us geographically, but closer in time, is the case of Chimney Rock in the American Southwest. It's part of the Pueblo and Chaco Canyon complex. So we're talking about the 1100s, 1200s here. And it's this natural formation. I'm sorry, this picture seems to have become rather pixelated. This natural formation, these chimney rock, that's what they call, the twin chimneys, that feature this great house, this kiva, that was built there for a purpose. These were ceremonial houses where people came together for big celebrations. And as seen from this great house, the moon rises in between the twin pillars of Chimney Rock once every 18 years when we are in a major lunar extreme year. By which I mean the moon is rising in a position the sun never rises, ever. And that's the photo I showed you before. This is a much better photo. That's the moon. That's the full moon. That's not the sun. No, it looks like the sun, but it's not. And you could say, well, yeah, sure. It could be a coincidence. Of course it could be a coincidence. However, a few years ago, 2011, the archaeologists excavating the Great Kiva, the Great House, they were able to date the wood that they found there. This is so dry, this is in Colorado or New Mexico, that it's so dry that wood is just preserved. And when wood is preserved to that level, you can actually date it dendrochronologically just by looking at the tree rings. And you can pinpoint the year precisely, in most cases. And all the ones that were analyzed, and this is the number of pieces of wood that were analyzed, have cutting dates. These are the years, so 1011, 1018, 1070. With the exception of one, they all coincide with a lunar standstill or lunar extreme year. Even though one of them is a minor, all the others are major. So what we can say, based on this piece of the archaeological record, is that they were reconstructing this great house at the specific years where this could be seen. So again, like the pig mandibles at Stonehenge, it adds weight to the archaeoastronomical argument that this was important, this was intentional.
What state is it in?
It's either Colorado or New Mexico. I can't remember, but I can find out and tell you after the break. And now for something different. Manhattanhenge. You've all heard of it. There's now a henge in every city, they say. But this was the first one, and it will be in the news very soon again, on July 13th and May 28th. What happens is that the sun sets in alignment with the Manhattan city grid. That's the sort of thing you get. This was not intentional, unless you think the Illuminati did this on purpose. And if you do, by all means, present us with some evidence, because that would be an amazing paper. But as far as research goes, it doesn't appear to be intentional. It happens. I told you before, the sun will rise and set in alignment with your house or anything else for 2 days of the year. And in this case, happens to be May 28th and July 13th. But I think the key point is actually being missed here. It's not whether this was intentional or not, originally. It's that for these people, for hundreds and thousands of people every year, it is intentional. They intentionally go there, even though it was not intentionally built that way. But they go there for the purpose of stopping traffic and taking this bloody photograph. Of experiencing the alignment is what I mean. And this actually is a much more important anthropological study that deserves to be made here. What's bringing these people there? Because what is bringing these people there is what was bringing people to Stonehenge 5,000 years ago. And in fact, this is even more similar to Stonehenge, because Mike Parker Pearson has suggested that the Stonehenge was built there because of these natural glacial fissures that are in the bedrock, that are by chance aligned with the winter solstice sunset. And this is where the avenue is now. So when they excavated the avenue, they found these natural fissures. If people like these people observed this coincidence by random chance and thought it to be meaningful, then they kept coming back year upon year, and then they built something out of it. I think that's what was happening to Stonehenge, and we're actually experiencing that at the moment, and no one is doing proper research on it. So I just wanted to highlight that in case any of you want to do that as a project. So as a finale to this long talk, I just couldn't leave without highlighting the problems and limitations we currently have. And that's because over the last 5 or so years, I've been focusing a lot more on looking at the field, looking at the theories and the methods from a reflexive point of view. What are the problems? Well, how can we move on from here? Rather than do field work, I've been focusing on this, which comes naturally when you're just doing teaching. You need to teach these things and suddenly you realize, well, this is rubbish. Why am I teaching this? And there's a huge problem in the field. It's cut across the entire field, and it's all the modern Western bias in the field. There's an emphasis on the sun over the moon and the stars. That's a modern Western bias, because the sun, we always know it's there. We feel it every day. We get up at sunrise. We go back to our house at sunset or whatever. We know it's there, but the moon and the stars we lost connection to. And so people focus on the sun. They really neglect the stars and furthermore the Milky Way. I could count the number of studies, archaeoastronomical studies, that use the Milky Way. It's 3. Okay? There's hundreds of papers on archaeoastronomy every year. There are 3 papers in all time that focus on the Milky Way. I'm actually now examining a PhD dissertation by a student from University of Bournemouth that uses the Milky Way a lot. So that's actually quite good and might be a paradigm shift. But for the moment, the stars are neglected. Archaeoastronomers actually reject looking at the stars. They think, oh, there's so many of them that you're always going to find alignment to the stars. But actually, there aren't that many of them because they are specific, they are different. Some are brighter than others, some have colors. All these things play against or in favor of some stars being important, maybe not all of them. And then the interpretations of these alignments. Why were people using them? They tend to be scientific. They were observatories. They were measuring devices. They were calendrical. There were astronomer priests that were sitting there and making these observations, like an astronomer sits in an observatory, or used to sit in an observatory and taking those measurements and photographs. Science is a very specific form of engagement with nature, which is unique to the West. Well, okay, it is unique to the West right now, but the Chinese had a very similar engagement with nature as well. But not all cultures are or should be expected to have that engagement with nature, to have a scientific approach to nature. When interpretations go beyond the scientific, they tend to remain in the symbolic. Oh, it symbolized this or that, which is kind of a bit of hand-waving. Yes, sure, of course it's going to be symbolic, because it's meaningful and therefore it's symbolic, but there's clearly something else that brought these people together to drag those stones from Wales and put them where they are today. Sorry?
They sparkle.
They sparkle, they do sparkle. That's a good point. And there's an overemphasis on statistical analysis, and I'm putting statistics like this because they're not statistical analysis. They are finding patterns. What happened in the 70s and 80s is that they were trying to find a statistical test that could be used for archaeoastronomy. And they couldn't find one that worked, because obviously the statisticians in the 20s and 30s and 40s, when all these tests were developed, weren't thinking about archaeoastronomy. So what they ended up doing was some hand-waving search for patterns, which is actually not robust from a statistical point of view. But they think this is the way of doing it, because this is the way they've been doing it for 20 years. And I'm actually working on developing a proper statistical framework. That's what I've been doing in the past year. And maybe next time I'll talk a bit about that, because I'm at the stage where I can apply that statistical framework to previous studies and check whether or not their interpretations were valid or not. And that's very interesting and controversial. Another issue is the lack of cultural contextualization. Archaeoastronomers tend to just go to the field, they measure, they check their numbers against the sky, and then they say, there you go, alignment with summer solstice. That's it. Okay, what about the culture that built Stonehenge? We know a lot about them. Why are you not engaging with that? Or the Puebloan people. I know I didn't do that today, because I didn't have time, but we know a lot about their cosmology that fits with this view that they would have built this great house there to observe the moon. And archaeoastronomers tend not to do that. They kind of stop at the level of identifying a target, a celestial target. There's lack of reflexivity, otherwise all these biases would have been taken care of. And there's no engagement with wider academic developments, with anthropology, with archaeology, with history. Archaeoastronomers have closed around themselves. They go to their own conferences, they publish in their own proceedings. They don't go to archaeology. They don't speak to archaeologists. They don't invite archaeologists to come to their talks. And that's why they think that what they've been doing for the last 20 years is okay, because they haven't realized that everyone else is doing much better stuff. And then, of course, we have to deal with these people, which are really damaging to our work. I'm talking here about the ancient aliens crap that is going around in many documentaries, and this guy, forgot his name now, is the key figure there. And I think this is a problem, that we're not engaging with this. We're not actually coming forward and saying, actually, no, what these guys are saying is ridiculous, here's the evidence. Because by not doing that, this is in the media. This sells books more than any other academic archaeoastronomy book. So even archaeologists, when they think of archaeoastronomy, they have this sort of stuff in mind. And it's damaging for us who are actually doing the good work. So just to close, if you're interested, if you want to know more, come to RAG, but also here's a selection of things you might want to explore. The Skyscapes book now only costs about 12 quid from Oxbow. It's a very good introduction to the topic. It covers different areas. Materiality of the Skies, conference proceedings. It's a very thick, shorter issues, but it really covers a lot of ground, including both archaeoastronomy, ethnoastronomy, and history of astronomy. The Journal of Skyscape Archaeology, which I co-founded and co-edit, is unfortunately not open access. We're still fighting that battle. But the editorials, the reviews, and the discussions are open access. And the discussions are very interesting because we are pitting archaeoastronomers against each other and against archaeologists. And they are open access, and they make for good reading and good citations. There is this free PDF, which I helped David create, which is Archaeoastronomy for Archaeologists, but it's actually an introduction to archaeoastronomy. It basically covers everything we've spoke about today and all the tools that are freely available. One of which is Stellarium, www.stellarium.org. Download it, it's free, it's open access, it's open source. It recreates the sky, you can play with it, you can do everything you want, you can get a better feel for what the sky is doing or has been doing in the past. And if you want know more about me, that's my website, skyscraper.net, not skyscape scraper. Easy mistake to do. You can actually download all my papers there, and that's my Twitter feed if you want to follow me. So that's it. Thank you very much.